Okay, this is the Prelab video of the experiment identifying an unknown substance. Okay. Now this is an experiment. Okay. So when you watch the experiment video, you need to take notes as if you were taking a notebook, as if you're really there conducting the experiment. And I've already outlined the proper format for a notebook in a previous video. So you need to review that. If you're uncertain how to conduct or carry out a notebook, make a notebook as the experiment is in progress. And after you do your notebook, you will need to scan it into a single PDF file, and that's what you will upload as your assignment. Okay. You need to download the department handout and read it. You need to read it thoroughly. It's very important that you do so. Otherwise, you will have a very difficult time getting the proper data and the proper calculations and answering the questions associated for the notebook. In the department handout is this table, okay? And you're going to have to use this table to identify the unknown. You're going to have an unknown solid and an unknown liquid, and we're going to take some measurements. We're going to determine the density of the unknown liquid and the boiling point of the unknown liquid. We're going to determine the melting point of the unknown solid and some of the solubility tests of the unknown solid. And based on what we determined from our experiment, we're going to compare these values to the table. The unknown solid is going to be one of these compounds, and the unknown liquid will be one of these compounds. So once we measure the unknown liquid, the boiling point, we'll compare it to the boiling points listed over here. Along with its density, get two confirmations and identify the unknown liquid. Same thing for the solid. I want to mention something over here, the solubility. We're going to be placing the solid into water, and we're going to be placing the solid into ethanol, and we're going to decide on whether it's soluble in either one of these. So I means insoluble. I means insoluble. S means soluble. Now, what does it mean for it to be soluble? Soluble is when the solid is placed into the liquid, and after you agitate, the solid disappears. It becomes dispersed homogeneously throughout the liquid. The liquid remains clear after the solid dissolves. Okay? There's no cloudiness, no turbidity at all. Insoluble, of course, that's pretty straightforward. The solid just remains into the liquid. It just sits on the bottom, or maybe it sits on the top. Right? It just never dissolves. This slightly soluble. Slightly soluble means that at room temperature, the solid is not soluble into the liquid, but if we heat the liquid, the solid does dissolve into the liquid, and that's what slightly soluble means. Okay? And you have keys down here to help you out in interpreting this table. But you'll need this table to compare with the data that you acquire from the experiment to identify your liquid and your solid. A couple other things. So, we're going to determine density of the liquid. Density is simply the mass divided by the volume associated with that mass. Right? Mass over volume. Now, we're going to determine mass using an analog top loading balance, and we're going to determine volume using a graduated cylinder. Now, details of that experiment. So here's a graduated cylinder over here. My best drawing of it. Right? So we'll determine the mass of the graduated cylinder, just the cylinder, right? Nothing that's in it. Then we're going to add some liquid to it, the unknown liquid, to the graduated cylinder. And then we'll determine the mass of the graduated cylinder that has the liquid in it. Okay? And the difference between these two is just going to be the mass of the liquid. Mass of the liquid. This value minus this value will be the mass of the liquid. Volume, well, we're going to use the graduated cylinder itself to determine the volume. Okay? So once the liquid is added, this is a representation of the liquid over here, you're going to have a meniscus, all right? A small curved portion where the top of the liquid is. Okay? And you're going to use the bottom of the meniscus relative to where the division is to measure the volume contained in the graduated cylinder. Now this is a graduated device, right? And I discussed how to get the correct number of significant figures from a graduated device in a previous video on significant figures. You may need to review that. It's very important that you get the correct number of significant figures from your measurements. If you don't, there will be pretty substantial deduction, right, in points. Significant figures are very important in the laboratory. They're important in scientific and engineering work, and you need to get used to using correct significant figures and being able to record correct significant figures. So it's not just going to be 1 or 2 points. Right? It'll be substantial deduction, so make sure your significant figures are correct. 2 things of the boiling point. So we take the boiling point measurement of a liquid. First, the liquid must be boiling, all right? So it's got to be bubbling. That's important. But just because it's bubbling doesn't mean that it's reached the boiling point temperature. So it's got to be bubbling, and the temperature must be constant. Right? So you're going to have we'll have a digital thermometer, and you'll follow the digital thermometer's temperature. And once that temperature remains constant while the substance is boiling, that is the boiling point temperature that you will record. Okay. That's about it for the experiment. It's pretty easy, straightforward. If you guys have any questions, feel free to contact me. Email, set up a Zoom, no problem at all. Do not be shy about contacting me. All right, that's what I'm here for. And I'm a pretty friendly guy, I promise you that. Anyway, that's all I have for this one, and I'll talk to you guys later.